Welcome, ladies and gentlemen. We are now looking at example 1 at determining the length of an arc. In this case, the length of arc A to B. Well, we're given this circle, and where you see this little arc here in 80 degrees, remember this is called the central angle because this is formed from the center of the circle. We're given that R is equal to 9. We need to determine the length of this arc from A to B. So arc AB is the same fractional part of the circumference as 80 degrees out of 360 is. Ooh, had trouble saying that one. Alright, to move on, because this is not going to take long, we can simply use the definition of fraction to help us find the length of arc AB. So let's see what fractional part of 360 80 is. And once again, before I move on, if you do not have pencil and paper, and if you're not writing this down and actively working on this, just sitting here and watching the video, this will not help you. So you need to have pencil and paper. You need to draw the diagram. At times you need to pause the video and do some scratch work on what I've shown you to make sure that you are assimilating what I'm presenting to you here. If you do not do that, then this video will not be of help to you whatsoever. Just looking at it and just watching it and listening to me, it will not be of any help. You must have pencil and paper. You must be working on this. Let's move on. So in this problem, we're using the definition of fraction, part out of the whole. 80 is part of 360, so 80 degrees out of 360. Well, in this case, we simplify it down by powers of 10. These zeros cross off. That's like saying 80 divided by 10, 360 divided by 10. That gives us 8 out of 36. But that can be simplified even more. And in this case, we see here that 80 is actually 2/9 of 360. Well, ladies and gentlemen, arc AB is 2/9 of the entire circumference. It has the same fractional percent, or if I turn this into a percent, the arc length is the same percentage of the circumference as 80 degrees is of 360. So all we have to do here now is know the definition of fraction. If you're given a central angle, reduce it or turn it into a decimal. And we're going to find out, well, what do we do now? Now that we know that arc AB is 2/9 of, well, usually in math, what does the word of usually represent? What operation does that usually specify right here? When I see the word of, well, the word of usually specifies to multiply. Well, the next thing we need to do is calculate the circumference of the circle. Let's see, how do we calculate the circumference of the circle? Well, we're going to determine the circumference of the circle, as I said before. I'll repeat it myself. So here goes the formula. The formula for the circumference, the measure around the circle. So we're looking at the measure around that circle. The circumference is the measure around the circle. That's equal to 2 times r times pi. For this circle, we were given that r is 9. So in place of r, we substitute the 9. So we now have 2 times 9 times pi. So the circumference of that circle is 18 pi. Well, we just discovered that the arc AB is 2/9 of the circumference. So in order to find the length of AB, we simply take that 2/9, multiply it times the circumference of the circle, and then simplify. So now I have 2 times 18 times pi divided by 9. Well, I noticed that 9 can divide into 18, so 9 divides it to itself once. 18 divided by 9 is 2. So now we have 2 times 2 times 4. Well, 2 times 2 times pi, not 4. So we now have in simplified form 2 times 2 times pi. I was already thinking the 4. So in this case, that's equal to 4 pi. So the length of arc AB is 4 pi. And all we had to do here is know the definition of fraction, how to calculate the circumference of the circle, and then multiply that circumference by the fractional part that we get by comparing the measure of the central angle to 360, because the arc length is in the same fractional proportion as the central angle is to 360. Ladies and gentlemen, there we go. Have a fun-filled day. This is your teacher and your instructor, Mr. Joshua Davis. Thank you for joining me.